All right, good afternoon or morning, whatever it is. I'm Mark Orr. I'm going to talk to you today about what agent-based models are. A very simple introduction that's just going to give you an overview of what they are, why we use them, and give you a couple examples. So what are agent-based models? So anyway, we're going to talk about what they are, why I use them, and a couple examples. So first, what are they? An agent-based model is a collection of autonomous agents that represent entities, and they could be anything. They could be a law firm, an individual, it could be a set of ants, it could be molecules. And the interesting thing about agent-based models is that the behavior of each one of these autonomous entities is actually dependent upon its environmental context. And, the behavior of each of the entities is also algorithmic. That means there's a very specific set of rules that dictate when and what the agent does given its environment. So, just for example, if an agent was a person, which a lot of the work with agent-based modeling is a person, the idea is that there's some kind of context, which could be the world. Okay, this is some kind of globe or some planet. And from the world, there's inputs, which we'll call I, that go into an agent, and the agent takes the inputs and processes them as a function of the input. And the processing is also what dictates the behavior of the agents. It's very simple. It's kind of like people. We have this assumption that people, they actually interact with their environments, and they make decisions on what to do in the daily context based on a set of rules to some degree. So that's basically what an agent is. We have an agent here that takes input from some kind of context from the environment, and then the behavior is a function of the environment, which is through some kind of processing. And the processing we typically call a set of rules, and that's what agents do. They process rules to try to the rules dictate their behavior. Okay, so why do we use agent-based models? First thing is that it allows you to really think deeply about processes and dynamics in a way that's difficult if you use other methods. The second is that it makes the assumptions that you're thinking about of any phenomenon, makes them very explicit. And third, it really is a way to have a clearer set of a principled way to think about a problem that you're dealing with. It lays out the logic very obviously to you, and from laying out the logic, it allows you to think more clearly about any problems that you come up with. So a couple examples. We're going to first look at an example in dealing with racial segregation. In the 1960s, a man named Schelling, he noticed that racial segregation in the United States was still very present even after we started to think deeply to some degree about civil rights. And he asked a simple question, which was, do individual preferences actually drive this? In other words, in the United States with racial segregation, how much racism do you really need? Is it individuals and their racist biases that are actually driving racial segregation? And he asked a more specific question, which is, what degree of bias is needed to produce segregated neighborhoods? So what he did was a very revolutionary idea, which was to take an agent-based model, and what you can see here are two different kinds of agents. So we have red agents, that's a green one, but this is a red one here. Okay, I see. It's a little bit off. So that's a red agent, a big one. And then we have green agents also. And they're spread out throughout this context. It's really a two-dimensional context. You can think of this as a neighborhood or a city or something like that. So we have the x and the y coordinates, which is a grid, just for simplicity's sake. You can imagine that each one of these agents lives in one of these small neighborhoods. And what the agent does, the set of rules that dictate an agent's behavior, is an agent decides, I didn't do that. An agent, take this for an example, an agent makes a decision if it wants to move or not. And what the agent does is it looks around in its neighborhood. For example, if this neighborhood is right here, and it computes the number of agents in the neighborhood that are like itself. And if it's not high enough, in other words, if there's not enough people just like the agent in the neighborhood, they decide to move. Very simple. And what you can do with a model like this is we set up this model, we just randomly threw agents out into the neighborhood. We didn't dictate where they're going to live. So there's a random distribution here, across here, of where they live. In other words, there's also a random distribution of the proportion of agents that are like you in your neighborhood. And what we do is we let this model run through time, and we decide, just for argument's sake, what if the preference was 75%? What that means is I'm going to move out of my neighborhood if at least 75, if the number of agents that are like me is less than 75%. So what we're going to do is we're going to run the model, and then we're going to show you the end result. And we're going to move right to the end result. It's not that surprising, but as the model goes forward in time, after a while you see neighborhoods that are highly segregated. These people live around red people. And you can see another big group here. This is a neighborhood of green people. Okay, so it's really interesting. So we can, at this point, this very simple model, it gives us some insight into the dynamics of and the change that we have in segregation due to this really simple rule of deciding, looking around your neighborhood, deciding how many people are like myself, and then using that as a decision basis to move. So we can also ask another question, which Schelling asked, which is, well, what percent do you really need? How low can it go? Do we need something like 50%? Will we still get this kind of segregation? Say it's 30%, 10%. What is it? We don't really know. Okay, it's a really hard question to actually answer without a model. But you can use your intuition, right? Now, if I said, what if people decided that they would move out of their neighborhood if 50% or less were like them in the neighborhood? That seems like it would probably not create much segregation. And what if I said to you, what if we went down to 30 or 35%? What would happen then? Well, what we're going to do now is we're going to look at 35%. Okay? We're going to do the same thing. We're going to initialize the model. Just going to put everybody in a random spot. And we'll run the model again. And you can see it's not quite as obvious, but it's very clear. There are huge patterns. That's where the red people live. And here's a group of green people. So even with a preference of only 35%, you still get a large degree of segregation. And this is something that Schelling, he showed to the world that we can, we have to be really careful about racial bias. If your goal as a policymaker, for example, was to reduce racial bias, you would have to reduce it probably a lot lower than you think, maybe to 10 or 15%. This kind of model, it doesn't necessarily mean that it gives you the exact percent. It just shows you that you're thinking about the problem. It's not easy to do without actually implementing the question into a model and then running a simulation to test some ideas. So, just to summarize, do individual preferences actually drive racial segregation? Well, according to the model, they do. So I say yes. This is provisional because it's just a model. It's a very simplifying model. It simplifies everything into two types of people. They live in a two-dimensional space, and they make the decision based on one single criterion. But given those limitations and the simplifications, we also, based on our simulation that we just ran, have a sense of what degree of bias is needed to produce segregation in neighborhoods. And the answer is at least 35%. So that's about all we have today. Thank you.